JEE Advanced 2025, Paper 1, Physics, Question 11. Let us visualize the setup. We have a solid glass sphere of refractive index √3 and radius r. Inside this sphere, there is a spherical air cavity of radius r/2. A thin glass layer at point O keeps the air cavity in place at the bottom. An unpolarized light source S is located inside the glass. The light ray travels from S, hits the inner surface of the glass sphere at some angle theta, and after refraction it reaches point O at the glass-air interface, where the reflected light is fully polarized. The question states, a solid glass sphere of refractive index n equals √3 and radius r has a spherical air cavity of radius r/2. A thin glass layer at point O keeps the air cavity inside. An unpolarized light source S emits a light ray from inside the glass sphere towards the periphery. The light is reflected from point O and is fully polarized. Find sin theta, where theta is the angle of incidence at the inner surface of the glass sphere. The key concept here is Brewster's angle. When unpolarized light strikes an interface between two media, the reflected light is fully polarized when the angle of incidence equals Brewster's angle. Brewster's law states that tangent of the Brewster angle equals the ratio of the refractive index of the second medium to the first medium. At point O, light travels from glass with n equals √3 to air with n equals 1. So tangent of theta b equals n air over n glass, which is 1 over √3. This gives theta b equals 30 degrees. Step 1. Finding Brewster's angle at point O. The light goes from glass with refractive index √3 to air with refractive index 1. For full polarization of reflected light, we need Brewster's condition. Tangent of theta b equals 1 over √3. Therefore theta b equals 30 degrees. This is the angle of incidence at the glass-air interface at point O. Step 2. Now we use geometry and Snell's law. The light from source S hits the inner surface of the glass sphere at angle theta. Since the sphere is made of glass with refractive index √3, and the light is inside the glass hitting the glass-air boundary at the sphere surface, we apply Snell's law. But actually, the light stays inside the glass after hitting the sphere surface, it refracts at the outer boundary and then reaches O using the geometry of the concentric arrangement and the condition that the ray must arrive at O at exactly 30 degrees, we can trace the ray path. Step 3. Applying Snell's law at the inner surface of the glass sphere. The light inside the glass hits the glass-air interface at angle theta. Using Snell's law at this surface, n glass times sin theta equals n air times sin r, where r is the angle of refraction. The refracted ray then travels through air or along a path that reaches O. However, considering the direct path, if the light travels from S through the glass and hits the glass-air boundary of the cavity at O directly, then at O the angle of incidence must be 30 degrees for Brewster's condition. Using the geometric relationship between the outer sphere of radius r and inner cavity of radius r/2 and applying the sine rule to the triangle formed, we get sin theta equals r/2 divided by r times sine of the supplementary angle. Solving this gives sin theta equals 0.5. The correct answer is sin theta equals 0.5. Exam tip: Brewster's angle problems are very common in JEE Advanced. Remember that tangent of Brewster angle equals the ratio of refractive indices, specifically n2 over n1, where n1 is the medium of the incident ray. At Brewster's angle, reflected and refracted rays are perpendicular to each other. Also, for glass-to-air interfaces, Brewster's angle is always less than the critical angle, so total internal reflection does not occur. Always draw the geometry carefully and use the sine rule for triangle-based problems involving spheres and cavities. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB.